Welcome to 3D Print Pulse, your essential weekly update from the cutting edge of 3D printing and additive manufacturing. Every week, we bring you the most important news and developments. The episodes are crafted by All3DP's expert editors and voiced by text-to-speech so that we can go hunting for news again. Ready for the latest? Let's dive right in.
It is no secret that the copyright in the 3D printing space is a big mess. You make content, share the content, signal your intent with a license on that content, and then it ends up on Temu or Etsy anyway, sold by someone else making a quick buck off your bright idea. Marry that thought with the fact that, for many 3D printer manufacturers, offering repositories and things to do with your printer has become a key part of the business. For years, the only solution was to fight it yourself, sending DMCA emails that usually get ignored, but MakerWorld is trying to change that. The platform has officially expanded its exclusive model copyright support system, moving it to a wider beta rollout. Here is how it works. If you are an eligible creator, now defined as having 300 or more followers, and you find your MakerWorld exclusive model being sold or shared elsewhere, you don't have to fight it alone. You submit a ticket with evidence, like your source files or a creation timeline, and MakerWorld's legal team steps in. They become your authorized agent, filing the takedown notices and managing the legal headaches with platforms like Amazon, AliExpress, and Etsy on your behalf. Enrolled users can apply for protections on their exclusive models up to 10 times per week. Why does this matter? Because platforms like Etsy often ignore individual creators. But when a $1 million company like Bambu Lab knocks on the door, they tend to listen. There are catches, of course. First, the model must be exclusive to MakerWorld. You can't use this service if you also post on printables or things. Second, you have to dox yourself to MakerWorld. They need your real legal name and address to file valid claims. But for designers tired of playing whack-a-mole with content thieves, this is a valuable feature coming from a manufacturer.
The electric vehicle industry has a dirty secret. It is addicted to rare earth metals. Currently, 95% of the world's EV motors rely on permanent magnets made of neodymium and dysprosium, minerals that are expensive, environmentally toxic to mine, and whose supply chain is almost entirely controlled by a single country, namely China. To break this dependency, engineers are turning to an old concept, the externally excited motor, which uses electricity to create magnetic fields instead of rare rocks. The problem? Historically, these motors are heavy, inefficient, and prone to overheating. But a new €25 million European research initiative is using 3D printing to solve that physics problem. By using multi-material additive manufacturing, researchers are now printing motor components with geometries that were previously impossible. Traditional copper windings are bulky and hard to cool. But with 3D printing, engineers can create complex, lightweight copper coils that interweave with ceramic insulation and steel cores. This allows for topology optimization, essentially letting a computer design the most efficient path for the electricity to travel, shaving off weight while boosting power. Even more impressive is the thermal management. Because they are building the motor layer by layer, they can print cooling channels directly inside the copper windings. This allows the motor to run harder and faster without overheating. The first results are promising. Prototypes are hitting 98% efficiency, matching the best magnet-based motors on the market while slashing raw material costs. By printing the cooling channels directly into the windings, they can also run harder and longer without overheating.
It is one of the oldest debates in 3D printing. What is the strongest infill pattern? If you ask 5 makers, you'll get 5 different answers. But, according to the latest data, the correct answer depends entirely on how you plan to break your part. For pure, raw compression strength, like a heavy weight sitting directly on top of a box, the classic honeycomb or triangular patterns are still the kings. They are geometrically efficient and incredibly rigid. The downside? They are slow. Your printer head has to make hundreds of sharp, sudden turns, which results in longer print times. If you want speed, rectilinear or grid is the default for a reason. It is fast and uses minimal material. but it has a fatal flaw. It is anisotropic. It is strong in one direction, but if you apply force from the side, it snaps easily because the lines don't reinforce each other. That is why the community has fallen in love with gyroid. Gyroid is more than a cool-looking squiggle. It is an isotropic pattern, meaning it creates near equal strength in every direction, up, down, and sideways. It is perfect for functional parts like drone arms or brackets where stress is unpredictable. The verdict? For a static display stand, use grid. For a heavy-duty bracket, use gyroid. And remember, the pattern matters less than the density. For a truly strong part, crank that infill past 50%. If you want to know more, follow the link in the show notes.
And now a word from our sponsor.
Are you an engineer or designer looking for high-precision CNC parts? Tired of waiting for manual quotes? Stop waiting. Craftcloud is your solution for instant on-demand CNC machining. Upload your CAD file, select from a wide range of materials, and instantly compare real-time quotes worldwide. Get the best price on precision parts, from rapid prototypes to mass production. We offer 3-axis and 5-axis milling, turning, and more. No minimum orders, just transparent pricing, fast delivery, and expert service. Craftcloud. We turn your CNC ideas into reality.
In the oil and gas industry, a tiny leak can mean $1 million problem. For ExxonMobil, that problem was a complex anti-wicking device buried deep in their turbine systems. It sits between electrical cabinets and rotating machinery bearings where it diverts excess oil away from critical instrumentation. But the traditionally manufactured version was a maintenance nightmare, a multi-part welded assembly that was prone to failing and leaking. So ExxonMobil teamed up with Louisiana State University, Nikon SLM Solutions, and Halco Group to rethink the part from the ground up. Using laser powder bed fusion, the team consolidated the multi-piece assembly into a single, monolithic 3D printed component. The results? The new design eliminates the welds that used to fail. It reduced the wall thickness from 8 mm down to just 2, saving weight without sacrificing strength. And most impressively, the manufacturing lead time dropped from months to just 31 hours of print time on an SLM 280 machine. Printed in 316L stainless steel, the new part is easier to service, significantly more reliable, keeps its high-precision geometry, and proves that even in the most conservative industries, additive manufacturing is no longer just for prototypes.
Let's round off this week's podcast with news bulletins. Prusa Research has launched a major new brand collaboration with fellow Czech company Skoda Auto. The partnership brings 2 official automotive colors to the Prusa line, electric green and emerald green. Available in both PLA and PETG, these filaments are exact color matches to Skoda's branding, allowing fans to print accessories or parts that perfectly coordinate with the automaker's livery. In a surprising pivot from AI and CGI, the BBC has turned to 3D printing for its 2026 Winter Olympics coverage. The broadcaster's promotional campaign, titled Trails Will Blaze, features a stop-motion world populated by 700 individually 3D printed athletes. The handcrafted promo highlights the tactility of the Winter Games, using miniature skiers and skaters to traverse a printed mountain landscape rather than relying on digital effects. Researchers from Cornell University are preparing for a final test of a new underwater 3D printer capable of building maritime infrastructure in situ. The machine uses a specialized concrete ink mixed with seafloor sediment, which is designed to resist washout while remaining pumpable. The team plans to print complex arches underwater this March.
That's it from the weekly roundup from the world of 3D printing. As usual, you can find all the links in the show notes. Thank you to our sponsor Craftcloud, and remember, you can always find more in-depth articles, reviews and guides at all3dp.com. Don't forget to subscribe and leave us a rating or review. It really helps us to bring these updates to even more 3D printing enthusiasts like you. Join us next week for another rapid-fire update. Until then, happy printing!